Hello everyone, welcome to Knowledge Hub by Sri Chaitanya. This is Shravan Kumar, Senior Chemistry Faculty. Now in this session we are discussing about the third part of electrochemistry. So already two sessions was completed. Now we are discussing the third session. In the third session we are discussing the Nernst equation followed by the electrolysis. So we are discussing the Nernst equation followed by the electrolysis. Okay, so first of all, in last session what we have discussed, that is how construction of, what is the construction of the galvanic cell, what are the changes that takes place, how current is produced, at which condition current is consumed, at which condition current is produced, we are discussed in last session. In this session we have discussed the what is the relation between Gibbs free energy and electrode potential. See, so according to Gibbs free energy, the relation is delta G is equals to minus NFE. Already we have discussed in spontaneity condition also. So based on this we get minus delta G is equals to NFE. Suppose if the reaction takes place in multiple steps, at that condition delta G1, this is the Gibbs free energy in first step, then the value is minus NFE1. Delta G2 is the second step. In the second step the value is NFE2. Number of electrons are 1 in first step, number of electrons are 2 in second step. Delta G3, this is the Gibbs free energy for the third step. So the value is minus N3FE3. By using of all these three, we get total delta G. G is equals to, delta G total is equals to, we get delta G1 plus delta G2 plus delta G3. Okay, different steps are involved. So substitute this value, delta G total is equals to minus NFE is equals to minus N1FE1 plus of minus N2FE2 plus of minus N3FE3. So minus F is common in left side. What we get here, NE is equals to, minus is common, F is common, then N1E1 plus N2E2 plus N3E3 we get. Minus F get cancelled, then N is cross multiplied, so E is equals to what we get here, N1E1 plus N2E2 plus N3E3 by N. N is nothing but total number of electrons in overall steps. So this is the important one to calculate the electrode potential if it takes place in different steps. So most important one, previously also we are get the question from this one in advance, so that's the most important one. So based on this one we get the question. See that one, the model type of question. See, the question is, this type of question they will ask in advanced examination. See the question. What's the question? 1 molar HClO4 solution is given. Formal potential is nothing but electrode potential for the different stage in the reduction of MnO4 minus 1 are given. That is, MnO4 minus 1 is turns to which one? MnO4 minus 2. What is the electrode potential here? E1 is equals to 0.564 is given. This is the first electrode potential, first step. Now second step, what happened here? MnO4 minus is converted to MnO2. So this is the E2 value. What is the E2 value? 2.26 volts is given. See the third step. What is the third step? MnO2 is converted to Mn plus 3. So this is the third electrode potential. What is the value? 0.95 volt. Last step, Mn plus 3 is converted to Mn plus 2. This is the E4 value. So different values are given, E1, E2, E3, E4 values are given. By using of this formal potential, then we have to calculate what is the change is takes place, what is the electrode potential is takes place for the conversion of MnO4 minus to Mn plus 2. This is the first question. See the second question, MnO4 minus 2 to Mn plus 2. For conversion, how much electrode potential is required? So based on the before this slide, we have discussed this formula. By applying of this one, we have solved the question. See the solving process. In first step, what is the electrode potential is given? E1 is given 0.564 volt according to the given data. See how many electrons are transferred from here to here. To understand this, calculate the oxidation number. So the oxidation number of MnO4 minus, I think all of you know, that is manganese X. 4 of minus 2 is equals to minus 1. X is equals to 7. So the oxidation number is 7 for MnO4 minus 1. MnO4 minus 2. 1 of manganese X, we don't know. 4 of each oxygen minus 2 is equals to minus 2. X is equals to 6. So what is the oxidation number here? 6 in MnO4 minus 2. Go for MnO2. MnO2. Manganese is X plus 2 of each oxygen minus 2 is equals to 0. X is equals to just wait, sorry. So X is equals to one moment. So I'm getting stuck in this one. See, sorry. See, here just now we are calculated. What is the oxidation number here? 7. We are calculated. Here the oxidation number is 6. Here oxidation number is 4. And oxidation number is 3. Here oxidation number is 2. And one more values, E1 value. What is the E1? That is equal to 0.564. N1. What is the change from here to here? The change in number of electrons are 1. That is equals to 1. Next, second stage, E2. What is the E2 value? 2.26 volts. What is the change in number of electrons from here to here? 6 to 4. That is equals to 2. E3. What is the third electrode potential in third step? 0.95. How many electrons are involved from here to here? 1. Because of 4 to 3 is nothing but change in oxidation number is 1. E4. What is the fourth electrode potential from Mn plus 3 to Mn plus 2? That is 1.51 volt. What is the N4 value? 1. Now from which one to which one we have to calculate? MnO4 minus 2, Mn plus 2. So according to first slide, here E total is equals to N1 E1 plus N2 E2 plus N3 E3 plus N4 E4 by N total. From here oxidation number 7, here oxidation number is 2. So from here to here, N value is equals to 5. Substitute that value. 5. N1 E1, 1 into 0.564, that is 0.564 plus 2 into this one, 2 6 are 12, 2 2s are 4 plus 1 5, again 2 2s are 4, 4.52 plus N3E3, what's the value? 0.95 plus N4E4, N4E4 value 1.51 into 1. So by calculating this you get the answer. Similarly, from here to here oxidation number is 6, here 2, change in oxidation number is 4, N value. Similarly like this, what is the E total? Is equals to, from here to it is changed, N2E2 plus N3E3 plus N4E4 by N total. What's the N2E2 value? That is already we are calculated, 4.52 plus 0.95 plus 1.51 by change in oxidation number is 4. That is the number of electrons transferred is 4. By calculating this you get the answer. This is a previous advanced model question. So mostly we are getting this type of questions. So you have to remember this one. Based on this one we are get the questions. Okay. So this is total depends on which one? Delta G is equals to minus NFE. This is the relation between Gibbs free energy and electrode potential of the cell. Now we are discussing about the next equation. So what's the use of the next equation? That is, next equation is explain the or gives the relation between electrode potential of the cell and standard electrode potential of the cell. So this can be identified by the, and also it is also gives the relation between electrode potential of the cell and equilibrium constant also. See here, according to Gibbs free energy, delta G is equals to, just now we have discussed, that is NFE. N is the number of electrons are involved in a reaction, F is the Faraday, E is the electrode potential of the cell. So F is nothing but Faraday, which is equals to 96,500 coulombs. That is charge of 1 mole of electron is known as the 1 Faraday. So based on that one we are getting this value. Now E is nothing but electrode potential of the cell, N is the number of electrons are involved in a reaction. Based on this, similarly, standard Gibbs free energy is equals to minus NF E naught. So the relation between delta G and delta G naught is relation between delta G and delta G naught is delta G is equals to delta G naught plus RT ln K. Here K is nothing but equilibrium constant. K is nothing but which one? Equilibrium constant. Equilibrium constant means the ratio of or rate of forward reaction, rate constant of forward reaction by rate constant of backward reaction. By solving this, what we are getting? Concentration of product by concentration of reactant we get. We can substitute this value in place of K also. Now here this is the equation A, this is the equation B, and this is the equation C. From A, B, C, see this one. From equation A, B and C, substitute the values. What we get here? Minus NFE is equals to minus NF E naught plus RT ln K. Minus NF is common in left side and right side, both side. To cancel each side, NF of E is equals to minus NF is common in right side. What we get here? E naught minus of plus minus. There is no NF, so that's why we get NF in denominator into ln K. Minus NF get cancelled. So what we get here? E is equals to E naught minus, but we have the one more formula. Ln is equals to ln is equals to ln get base e but log get base 10. The relation is 2.303 times. Ln is how many times is heavier than compared to log 10? That is 2.303 times is heavier compared to the log 10. Substitute that value. What we get here? 2.303 RT by N into F log K. R is nothing but which one? Universal gas constant. If you substitute the value, R value, T is the temperature, F is the Faraday. By substituting of all these, finally we get E is equals to E naught minus 0.059 by N into log K. This equation is known as which one? Next equation. Okay, so what's the next equation? E is equals to E naught minus 0.059 by N into log K. So this one is gives a relation between E naught and K. Okay, now suppose what's the next equation? E is equals to E naught minus 0.059 by N into log K. Suppose if, see the question, so I am going to give the one question to solve. See the question. So in this question here, the question is Zn is converted to Zn plus 2. Its concentration is C1 because of this is in present in aqueous medium. This is a solid. Cu plus 2 aqueous, concentration C2, Cu solid. Now condition for spontaneity. Condition for the spontaneity. See the options. C1 is greater than C2. B. C2 is greater than C1. C. C1 is equals to C2. D. A and B. This is the question. Now how we solve this? That is we can solve by using of next equation. See the first of all, to identify the spontaneity condition, see the first of all write the overall equation. Left side reaction is according to our general representation. Left side is a which reaction? Oxidation. Right side reaction is a reduction reaction. Write the reaction. Zinc is converted to which one? Zn plus 2 plus 2 electrons. Here it is in aqueous medium. Right side which reaction? Sorry, this is the oxidation. Right side is the reduction. What is the reduction reaction? Cu plus 2, gain the 2 electrons, then converted into Cu. By the overall equation, 2 get cancelled. Zinc solid, Cu plus 2, it is a aqueous medium, gives rise to Zn plus 2, it is in aqueous, plus Cu, it is in solid one. Its concentration is C2, concentration is copper, concentration C2, zinc concentration is C1. Both are present at equilibrium based on the condition. Now condition for the spontaneity. Spontaneity condition, what is the spontaneity condition? Spontaneity condition is already in last session we have discussed, that is electrode potential of the cell is must be positive value, not the negative. For getting the positive value, substitute the values. So E is equals to E naught minus 0.059 by 0.059 by how many electrons are involved? 2 log K is nothing but concentration of product by concentration of reactant. Concentration of product, what are the product here? Zn plus 2 into Cu by reactant. What are the reactant? Zn Cu plus 2. Suppose if E naught value is equals to 0. Suppose, let this value, standard electrode potential value is taken as 0. Then what we get here? E is equals to minus 0.059 by 2 log. Here copper and denominator zinc, both are in solid form. Generally solids are having the concentration is equals to 1. For solids always concentration is taken as 1 because of densities are doesn't change. So based on that concept, concentration of solids and pure liquid like water, concentration is taken as 1. So what we get here? Concentration of copper is equals to concentration of zinc is equals to 1. So based on that one, what we get here in numerator Zn plus 2. Zn plus 2 concentration is given as C1, denominator concentration is given as C2. But what is the condition for the spontaneity here we have discussed? Electrode potential of the cell is must be positive. But by calculation, what is the sign you are getting? Negative. For getting positive, change the numerator and denominator. 0.059 by 2. By changing numerator and denominator in log, minus became plus. So what we get here? Log C2 by C1. At which condition we are getting positive value? If C2 value is greater than C1, then electrode potential value became spontaneous. So what's the option is correct in this one? C2 is greater than that of C1. So this option is correct. Okay. If E naught value is taken as 0, then we get this. Okay. So in this way we are solve the problems based on the given data. So this is the relation between electrode potential of the cell and standard electrode potential of the cell and equilibrium constant. C. Okay. So if you want to know more about the knowledge hub, what are the courses we are offering? If you want to know, please scan this, then you will get the entire information. Okay. Next. Here in this one, after the next equation, we are discussing the electrolysis. So before that, first of all, we are discussing about the electrolyte. So which substance is acting as electrolyte? Electrolyte is nothing but the substance which allows the flow of current either in solution state or molten state. Then the substance is known as which one? Electrolyte. Okay, what is the definition? Which allows flow of current. Sorry. Which allows flow of current either in which state? Either in molten state or solution state. Which allows the flow of current either in molten state or solution state. That is known as the electrolyte. Suppose molten state is nothing but liquid form of the substance without water. Suppose if you take this sodium chloride, it is generally exists in which form? Solid form. By heating, what happens? Solid form of sodium chloride is turns to liquid form. That liquid form is known as the molten state. Here in this one, if you take this sodium chloride, generally here no ions, no free ions are present in solid state. So that's why it is a insulator. Because of for passage of current we require the ions, but in solid state there is no free ion, no free electrons are present, so that's why it is acting as insulator. But on heating, sodium chloride is turns to Na plus Cl minus. Here lack of electrons are present, here excess of electrons are present, so that's why electrons are the flowing of electrons is nothing but current. So current is passed from one ion to another ion, so that's why this is the molten state. In molten state it is acting as which one? Conductor. So this one is acting as which one? Electrolyte. So the substance which is allows the flow of current either in molten state or solution state. Solution means if you are add the water, again you get the ions, free ions, so easily current is passed. So that's why that one is acting as which one? Electrolyte. Now what is the definition of electrolysis? Electrolysis is nothing but the process in which substance is decomposed and converted into its parental atoms by applying of current. Then the total phenomena is known as the which one? Electrolysis. Electrolysis is nothing but the process of conversion or the process in which compound is splitted into or electrolyte is splitted into its compound is decomposed and produces its parental atoms. Parental atoms is nothing but produces its parental atoms by passing of EMF. EMF is nothing but electromotive force, that is nothing but current. By passing of current, if it is produces its parental atoms. If parental atoms are produced by passage of current, then the total phenomena is known as electrolysis. Okay, so in this electrolysis we use the electrolytic cell. This is the electrolytic cell. To make the electrolytic cell we require the two electrodes. One is called as the cathode, another one is called as the anode. Here from this one electrons are enter into the solution. From one electrode electrons are enter into the solution. From another electrode electrons are away from the solution. Okay, so from one electrode electrons are enter into the electrolytic solution. From another electrode electrons are away from the solution. So from one electrode electrons are entered. So what happened? It get the more negative charge. So negatively charged electrode is called as the cation. Why it is called as the cation? Sorry, cathode, not cation, sorry. It is a cathode. Why it is called as the cathode? Because of from this electrode electrons are enter into the electrolytic solution. So it get the negative charge. So it is called as the cathode. From another electrode electrons are away from the solution. It is called as anode. It gets the charge? Positive charge. Because of electrons are passed away from the solution. So that's why it gets the charge? Positive charge. So at cathode get the negative charge, anode get the positive charge. So negatively charged particle is attracted by the cation, whereas positively charged electrode is attract the negatively charged anions. Okay, here cation get the positive charge, anion get the negative charge. So cations are migrated towards cathode, anions are migrated towards the anode. See what happened here? Cathode get the which charge? Negative charge. Which ions are attracted? Positively charged ions are attracted. Attracts the cations. So what is the charge of cation? Positive. Okay, whereas anode anode get positive charge. Why it get the positive charge? Because of from this electrode electrons are away from the solution, so that's why it get the charge, positive charge. So it attracts the anions. Anion charge is negative. So what happened? Which reaction is takes place at cathode? Which reaction is takes place at anode? Let us take the example. NaCl, molten form, that is molten NaCl. Molten NaCl means only sodium chloride is present. On heating, what happened here? Na plus Cl minus ions are existed. Okay, now cathode. Cathode means what's the sign of the cathode? It get the negative charge. Anode, it get the positive charge. So negatively charged cathode is attract the opposite charged ion, that is Na plus is attracted towards the cathode, then converted to sodium. Whereas negatively charged ion is attracted towards oppositely charged electrode, that is Cl minus is turns to half Cl2 plus electron. So by passage of current, what we get here? Sodium and chlorine. These are the parental atoms for which one? Sodium chloride. From these sodium chloride is produced from sodium and chlorine. So parental atoms are produced by passage of current. That's why this total phenomena is known as which one? Electrolysis. Okay, remember this. So why cathode get the negative sign? Because from this electrode electrons are enter into the solution. Why anode get the positive charge? Because of from this electrode electrons are away from the electrolytic solution. So anode get the which charge? Negative charge. Here cathode get the positive charge. At cathode what happened? Electrons are gained. Electrons are gained means what happened here? Reduction reaction. So at cathode reduction reaction takes place. At anode what happened? Electrons are loosed. Losing of electrons are known as the oxidation. So at cathode reduction reaction, at anode oxidation reaction takes place. Overall what happened? Redox reaction takes place. Okay, both oxidation and reduction reactions are takes place. So that's why in electrolytic cell what happened here? Both oxidation and reduction reactions are takes place. This is a molten NaCl. Now take the second example. Electrolysis of aqueous NaCl. Aqueous NaCl means sodium chloride is present along with water. What happened here? NaCl is present in water, simultaneously water. When you are passing the current through the electrolytic solution, then what happened here? Sodium chloride is split into Na plus and Cl minus. Similarly, water is dissociated into H plus and OH minus. So two cations we get, two anions we get. So cathode, what is the sign of the cathode? Negative charge. Anode, positive charge. Which ions are migrated towards the electrodes? Because of in this condition we get the two cations and two anions. Which ion is migrated? We get the one doubt. So to overcome this doubt, we use the discharge potential order. We have the which one? Discharge potential order. So this is the order of discharge potential of cations and this is the discharge potential of anion. So discharge potential order of cations. So in this, which ion is migrated? The ion which shows more, which one is showing the which one is shows the less discharge potential, that is discharged first. the ion which shows less discharge potential, that is discharged first. Less discharge potential, that is discharged first. This is the discharge potential order of anions. Here also same, ion with low discharge potential is discharged first. See the previous slide, which ions we have? Sodium and H plus, Na plus and H plus ions we have. See the discharge potential order. Which is having the low discharge potential? See, sodium is present here, H plus is present here. Which one shows the more discharge potential? Sodium is a more discharge potential, hydrogen is a less discharge potential. This is the discharge potential order. Okay, which one is having the more discharge potential? Na plus shows the more discharge potential than compared to H plus. Next, see the previous slide, Cl minus, OH minus, two anions we have. In this one, this is the order. What is the order? Which one shows the more discharge potential? OH minus is more than compared to Cl minus. So which ions are discharged first? That is ion with low discharge potential is discharged first. So this ion is discharged, here this ion is discharged. See what happened discharging? Cathode. Discharge potential is nothing but the capacity of losing of its charge is known as the discharge potential. Okay, so which ion is discharged at cathode? H plus ion is discharged by gaining of electron, produce the half H2. At anode, anode is the positive charge. So which ions are migrated? Because of two anions we have, low discharge potential is for the chloride. So what happened? Cl minus is turns to half Cl2 plus electron. So what are the leftover ions here? Na plus is left over here, OH minus is left over. So what we get here? Na plus OH minus gives rise to NaOH. Okay, so what are the compounds are we get? H2, Cl2 and NaOH. This is the discharge potential order. See, molten NaCl, aqueous NaCl. What are the products we get in this? Here Na, sodium and chlorine is produced. But here what are the product we get in aqueous NaCl? See the previous slide, half H2, that is hydrogen gas is produced, chlorine gas is produced, NaOH is also produced. Here only sodium and chlorine gases are produced. But here what are the product? H2, Cl2, NaOH. By electrolysis of molten NaCl, there is no change in pH. That is pH is equals to 7 only. But in aqueous NaCl, by electrolysis, after the electrolysis process, what we get here? Base we get. So for bases pH value is greater than 7. Here pH value equal to 7, here pH value is greater than 7. So they ask the question, in which of the following forms basic solution after electrolysis? That is aqueous form. Okay, so this is the important one. Let us take the one more example. Molten example, suppose if you take the potassium chloride. Here also electrolysis of aqueous KCl. See, Molten KCl means only potassium chloride is present. What we get? K plus Cl minus we get. For passage of current, we require the two electrodes, that is a cathode, and second one is the anode. What is the sign of the cathode? Negative. Anode is positive. Negatively charged electrode is attract the opposite charged ion, as of already we know. By gaining of electron we get potassium. At anode, Cl minus is converted to half Cl2 plus electron. Okay, so potassium and chlorine gases we get by electrolysis of molten KCl. But if you see the aqueous KCl, aqueous means water is present along with KCl is present. By passage of current, what we get here? H plus Cl minus. How we get? K plus, sorry, here it is the OH minus, here Cl minus. Okay, so we have the two cation, two anions. Cathode, anode. Cathode is a negative charge, anode is a positive charge. Which ions are migrated? See, because of two ions we have H plus and K plus, OH minus and Cl minus. So out of these two, which shows a more discharge potential? See, discharge potential order, potassium is here, hydrogen is here. So out of potassium and hydrogen, which one shows the more discharge potential? That is, potassium shows the more discharge potential. Next, OH minus and Cl minus. So OH minus and Cl minus, sorry, OH minus and Cl minus. Which one shows this more discharge potential? OH minus shows the more discharge potential than compared to chloride. So which ions are migrated towards the electrode? Here K plus is migrated. Sorry, not this one. Here H plus is migrated and here Cl minus is migrated. So by migration of these we get the product C. So H plus gain the electron, then produce the half H2. Anode, anode is the positive charge. So which ion is migrated? Cl minus, half Cl2 plus electron. What are the leftover things? K plus OH minus is left over. We get KOH. In this way we get the questions. Okay, so we get the in molten KCl, aqueous KCl, we get the different product. So while you are solving the objective, be careful which ion is discharged first. So which ion is discharged first? See, lithium is more discharge potential. Lithium, potassium, sodium, calcium, magnesium, aluminum, manganese, zinc, chromium, iron, protium, that is H plus, copper, mercury, silver, platinum and rhodium. This is a discharge potential order of cation. If you see the anion, fluoride, phosphate, sulfate, nitrate, hydroxide, chloride, bromide and iodide. This is for the discharge potential order of the anions. Okay, based on that one we are solved the one problem. See, another model, most important, electrolysis of 50% concentrated H2SO4. 50% of H2SO4 is nothing but half of the ratio is water, half of the ratio is sulfuric acid, aqueous. At this condition, what are the product we get? Okay, this is a question is given to you. In next session I will give the answers. Okay, electrolysis of 50% of sulfuric acid, what are the product? And another question, this is the first one. See this second one. Electrolysis of Na2SO4 aqueous. What are the product? So these are the homework keys I want to give to you. So try to solve this one. Otherwise, in next session I am going to give the answers for this. Okay. So this is the this is the electrolysis process. So in electrolysis process, what we get? Electrolyte. Electrolyte is nothing but the substance which allows the flow of current either in molten state or solution state. Then that is known as the electrolyte. What is the electrolysis? The process of decomposition of a electrolyte into its parental atoms by passing of current. That is known as the electrolysis. For electrolysis, here two electrodes are required. What are the two electrodes? Cathode and anode. Why cathode get the negative sign? Because of from this electrode electrons are enter into the solution. From anode electrons are away from the solution. So anode get the positive sign, cathode get the negative sign. So at cathode what happen? Electrons are gained. That means reduction reaction. At anode oxidation reaction is takes place. Okay. So these are the questions I want to give to you. Copy this. In next session I am going to give the answers for this. Okay. So thank you. If you want to know more about the knowledge hub, please scan this, then you will get the total information about the knowledge hub center. Okay, if you have or if you face any problem or while solving the objective or while reading the electrochemistry, comes to the nearest knowledge hub center. Okay, thank you.